Okay, hello and welcome to another video. This was on a question which James showed me the other day in class, just right at the end. I'm pleased I didn't try and do it in the 4 minutes I had, because it's just not a 4-minute question. It really isn't. It's quite a long question. I'm going to do it with factor formulae, which is these formulae here, but then I'm going to do it without factor formulae, which, to be honest, is the easier way in this kind of question. It's not always obvious though what's going to be the easier way, but I guess the hint is, if they give you some trig, like if they said let P be 2 cos alpha sine alpha, let Q be 2 cos beta sine beta, that's when they're nudging you that you need to use the trig equivalence for the general points on the ellipse. And if they don't do that, then I guess we're not supposed to use the trig equivalence for the general points on the ellipse, or at least they're not suggesting that it's necessary to. But let me show you the way which I initially first thought of doing it. Okay, so we've got P and Q, 2 distinct points on the ellipse. So turn it into more of a, the format which it's in the formula book, and then we can see that P is 2 cos alpha sine alpha, and Q, which is a different point, I'm going to call 2 cos beta sine beta. Now my general strategy, whether I'm using trig or not, is I'm going to find the equation of the line L, because it's just a chord from P to Q, and then I'm going to find where the tangents at P and Q meet, and I'm going to try and show that this holds in both cases. Yeah, that's essentially what I'm doing. So okay, let's make a start. Let's find the gradient of PQ, by which I'm going to do change in y divided by change in x. Now I've already written all this down, because otherwise it just takes too long for me to write down. You'll get bored of the video basically as I slowly copy it down, because there's so much trig to write down. When I take the approach without the trig, I'll try and do that live, not have it all written down. It will be easier to do because it's like not quite as algebraic intensive. Okay, now whenever you get these kind of expressions, this is exactly where factor formulae come in useful. I'm just going to employ that one on the top, and I'm going to employ that one here on the bottom. And if you notice, we get a lovely bit of cancellation there on these two terms, and so you end up with minus a half cot alpha plus beta over 2. Great, we have the gradient of the chord. Now we're just going to use y minus y1 equals the gradient times by x minus x1. And I think here, to simplify this, here's one of the tricky bits. I'm going to multiply by 2 sine alpha plus beta over 2. Yeah, I'm going to multiply both sides of the equation by that, because that will change the half cot into just a cos a plus b over 2. And on this side, you're going to get 2y sine a plus b over 2 minus 2 sine alpha sine a plus b over 2. And on the right hand side, if we multiply out the brackets at the same time, which is a bit risky because we're biting off a lot of work in terms of algebra there, we're going to have to do x times cos alpha plus beta over 2, because the sine alpha plus beta over 2 has been times on the left hand side, and the half has disappeared because I've times by 2, and now I'm going to be timesing cos alpha plus beta over 2 times by 2 cos alpha, and so because of the minus signs, 2 minuses make a plus, and you get 2 half. Look, there's a little mistake there. That needs to be a cos. Let me just change that. Easy to make mistakes in these questions, isn't it? Cos alpha plus beta over 2. Okay, great. Now, this does tidy up. Always look for an opportunity to tidy. Put the x's and y's on the same side, and put all the other junk on the other side, and you'll see you get 2 sine alpha plus beta over 2 plus cos alpha plus beta over 2. Now you can use compound angle, cos A plus cos B, cos A cos B plus sine A sine B is cos A minus B, to simplify this, and it will go to 2 cos one angle minus the other angle, and that actually simplifies, if you think of that alpha as 2 alpha over 2, to alpha minus beta over 2, and so we end up with a very important result here, all simplified. That's the equation of L. And actually, I think I'm just going to change back into black to make it a bit clearer. Okay, so lovely. Now, in fact, let me highlight it. Yeah, that's a really important step. Firstly, it's bound to be work method marks. That's the way I see it. So, even if you don't get all 8 for this question, it is a difficult question. There's no doubt about that. If you can get 3 or 4 out of 8 on the worst question in the paper, you're doing really well, aren't you, really? Okay, so what I did next was I thought, well, I want it to kind of be of this format, this 4sy plus rx equals 4. So I thought I'm going to change that 2 cos alpha minus beta over 2 into a 4. Now how can I change it into a 4? Well, I could double it, and I could divide both sides of the equation by cos alpha minus beta over 2. So that's what I'm going to do to come to this setup So I've doubled my coefficients, and I've also divided them by cos alpha minus beta over 2. Because then I can say, okay, if this equation holds as the equation of the line L, then S must be sine alpha plus beta over 2 divided by cos alpha minus beta over 2, and R must be 2 cos alpha plus beta over 2 cos alpha minus beta over 2. And all I'm doing there is I'm comparing it to 4sy plus rx equals 4. Let me write it down next to it. 4sy plus rx equals 4. So I've got the 4 there, so that's the same. I've got the 4y here, and so this bit must be s. And I've got the x there, so the 2 cos alpha plus beta over 2 cos alpha minus beta over 2 must be r, yeah? So, you know, basically I'm saying it appears that. Yeah, so it can be written in that form, provided s genuinely equals this and r genuinely equals that. So my next step is, let's check with the tangents, because that's just a chord. Let's find where the tangents intersect. So we do our normal way of finding the tangent to an ellipse. We find dy by dx by differentiating y, differentiating x, and differentiating y with respect to alpha, differentiating x with respect to alpha, and simplifying it, and you get a minus a half cot alpha again, or a very similar, you know, result to what we had last time. Okay, so we're going to do y minus y1 is gradient times x minus x1. We're going to times once again by 2, that's cos over sine, so let's times by 2 sine alpha, both sides. So this becomes 2y sine alpha, and this becomes minus 2 sine squared alpha. That becomes minus x cos alpha once you've times it in, plus 2 cos squared alpha. Put the sine squared with a cos squared, you get a lovely 2 there. And so you get this as your general equation for the tangent at P. And likewise for Q, you're going to get that for your general equation for the tangent at Q. And then what we can do is we can solve these two simultaneously to find y and to find x. Now hopefully, because these coordinates are supposed to be the coordinates RS, hopefully the y coordinate will be the s that I found before, will be this, yeah? That's what I'm really trying to do. So let's actually do it. Now if you just take this side of my working, all I've done here, and it's a bit scrappy because I'm getting a bit tired of the algebra at this time, I've times the tangent at P by cos beta, let me make that clear, times that one by cos beta, and I've times the tangent at Q by cos alpha. Now why, you might think? Well, it's so I get exactly the same coefficients on the x terms. So I've called the tangent at P after timesing by cos beta A. So this is 2y sine alpha cos beta plus x times cos alpha cos beta equals 2 cos beta. And I've called the tangent at Q after timesing by cos alpha B. And that gives you 2y sine beta cos alpha plus x cos beta cos alpha equals 2 cos alpha. And then I'm just going to subtract to get rid of the x coordinates, and I get 2y sine alpha cos beta minus sine beta cos alpha equals 2 cos beta minus alpha. And if I divide by the, well, cancel the 2's, divide that by that, and also use the compound, the factor formula again to turn this into all of that, yeah? And you're going to get eventually, now, here's the last tricky bit. Sine alpha minus beta is what this equals. That's going to give you, if you use double angle formula this time, yeah, this is like sine x, and it equals 2 sine x over 2 cos x over 2. So I'm using kind of a half angle approach to the double angle formula here. So I halve that angle and make it 2 sine alpha minus beta over 2 cos alpha minus beta over 2. And if you look, because I've got a sine beta minus alpha over 2 here, which I can turn into a minus sine, let's get this right. Yeah, let me just check this. Hang on, I think that's actually slightly wrong. Let me just quickly correct that because I've written that down slightly wrong. If we just look, let's bring the actual formulas which we need down here because it'd be handy to be able to see these. Sorry, my son keeps playing Sonic the Hedgehog on this thing and I can't get a theme tune out of my head. Okay, so what were we putting on top here? Cos beta minus cos alpha. And cos beta minus cos alpha, well your beta's A and your alpha's B, which is annoyingly confusing, is going to lead to minus 2 sine beta plus alpha over 2, and then beta minus alpha over 2. Yeah, it is correct at the moment. I'm just going to get rid of this. Okay, so what cancels here? Well, what we're going to need to do is turn that beta minus alpha into sine alpha minus beta over 2 by using the fact that sine is an odd function, yeah? And then I can cancel that minus with that minus, the 2's cancel, that minus cancels with this minus, and the sine alpha minus beta cancels with what I've turned into sine alpha minus beta now. And so you get sine alpha plus beta over 2, cos alpha minus beta over 2, and that is in fact S. Woohoo! We've almost finished it now. There we go, that's S. To do the same thing for R, you just repeat the whole process again, but instead of eliminating the x's, you could eliminate the y's. Now I won't spend too long on this because it's exactly the same process and it gets a bit tedious. So times this all by sine beta, times that one all by sine alpha, you get these two equations. You'll subtract them to get rid of all the y's, so you'll have x. It works exactly the same way. You're going to use double angle again on the bottom and eventually end up with 2 cos alpha plus beta over 2 cos alpha minus beta over 2, and that is of course R. So, okay, that's one way of doing it, yeah? Now, that's definitely not the easy way, is it? look at what we've done there, right? So let's look at the easier way, yeah? But it's always nice to look at scenic routes to the answer because, you know, gradually you can try and avoid them. But, I mean, that said as well, isn't it better to have a long way to get to an answer which works rather than no way to get to the answer? So that's one way of doing it. The other way of doing it is to say, okay, let P equal xp yp, and q can be xq yq, yeah? Okay, so we don't actually need any of the trig stuff to do this, we really don't. And I guess, like I say, the hint is the fact that the question doesn't mention a trig function. That must mean that, like, you know, you might guess then that maybe it's not necessary. Okay, so I'm going to use exactly the same approach though. It's going to be identical in terms of strategy. I'm going to find the chord first. Yeah, so let's just deal with the chord. The gradient of the chord is going to be yp minus yq over xp minus xq. It does get confusing this way as well. This isn't, you know, really simple. It's not massively easy. It just means you don't have to write down loads of trig. Okay, so y minus yp is the gradient. And the problem with this way is that you get muddled with the y's, x's, yp's and yq's and xp's and xq's. You've got lots and lots of different letters there. Okay, if we multiply this out and simplify it, what do we get? We get times this over here, yxp minus y. Oh, look at that, I've already made a mistake. Yeah, xp minus xq. So yxp minus yxq minus ypxp plus ypxq. Careful with the ordering here. Remember, you're multiplying that into the bracket, so you're going to get xyp minus xyq. Try and be consistent with the order in which you put the letters as well. Always put the variable first or last, whatever you're going to do, but just be consistent. Okay, and then minus xpyp, and actually I'm going to mark that as minus ypxp just because it's the same on the other side, because then that cancels, minus ypxp. Then I'm going to have plus xpyq. Oops. Now something does cancel here this term. These terms don't cancel, although they might look like they do because it's a yp and an xq, and this is an xp and a yq. So what we can do, remember what we're trying to achieve here as well. We're just trying to achieve a tidier version of the formula, really. That's what we're trying to do. So in answer, what have we got here? Right, let's put the y's and the x's on the same side. And I'm not talking about xp's, yp's, xq's and yq's there. I'm just talking about the y's and the x's. So I'm going to factorize this out again actually as well. I'm going to have y times xp minus xq. And then if I add this over, I'll have plus x times yq minus yp. And I think that's nice. X times yq minus yp. And that's going to be equal to, and then let's dump the junk on the other side, xp yq minus yp xq. Yeah, because they're all constants, that's not really a variable. Yeah. Now, once again, I'm going to try and turn it into this format so I can identify what S and R should look like. That's essentially exactly what I did last time, but it just took me a bit longer because I was faffing about with trig. So what do we want? We want a 4 sy, and we want equals 4. So if I divide this side by what it is and then times it by 4, I'm going to times by 4, and I'm going to divide everything by xpyq minus ypxq. Yeah? And then that's going to give me 4y xp minus xq over xpyq minus ypxq plus 4 times x yq minus yp over xpyq minus ypxq. Okay, equals 4. Yeah, I've got it in that lovely format again, so I can immediately identify, well, S must be that. Maybe I can just do this in a different colour. Yeah, and I guess R, well, R's, because it just equals Rx, R must equal 4 times. Well, let's just put it like this. I guess R over 4 equals YQ minus YP over XPX YQ minus YP XQ. Yeah. So yeah, there we go. Like, got it in a nice format. Now, back to what we were doing before. This time we're going to find the tangents. Okay, well, finding the tangents, so that's just a chord. Tangents, you see, it's not easy as in like, oh, it's going to take 2 seconds this way. No, it still takes a while. Now, if you remember, we had, what was the original equation? X squared plus 4y squared is 4, yeah? And so 2x plus 8y dy by dx is 0. That leads to dy by dx is minus x over 4y. And of course, we're going to plug in our points for P and Q. Now remember, P was xp yp, and Q was xq yq. Okay, so we just plug them in. Let's just do it for P, and then we can say it's exactly the same for Q, because it's going to work exactly the same for Q. Okay, so y minus yp is minus xp over 4yp multiplied by x minus xp times the 4yp over. You're going to get 4y yp minus 4yp squared equals minus x xp plus xp squared, I believe. Check that for me. Now, have a look at this. Like, always look. This is kind of a critical point in you solving this question, because if you don't do this, you're going to go into algebraic hell and probably not get the answer. But have a look. If you move this onto this side and think for a second, both xp, yp and xq, yq solve this equation. Why? Because both p and q lie on the ellipse. So we can just immediately turn 4yp squared plus xp squared into 4. That will make the question considerably easier. Yeah, always look for shortcuts in your algebra. Likewise for q, yeah, if you don't take the algebraic shortcuts, you tend to make errors, don't you? That's the way I see it. So for q, it's just going to be exactly the same, but p's replaced with q's. Oh, getting really sloppy there. Now we've just got to find R and S, i.e. where they meet. Now, exactly the same strategy, really. I'm going to eliminate x by timesing this one by xq and this one by xp. If you compare what I'm doing here, it's exactly the same, but just without the trig. So I get 4y yp xq plus, if you like, oh, my handwriting's getting worse, x xp xq equals 4xq, 4y yq xp, so I'm using the other equation now, plus x xp xq equals 4xp. When you subtract them, you get 4y yp xq minus yq xp equals, because they cancel, 4 xq minus xp, the 4's cancel, and sure enough your y coordinate, which if you remember, because we're dealing with the coordinates rs, this is your s, which is your y coordinate, is going to be xq minus xp over yp xq minus yq xp. Now let's see if that's right. Have a little look up here. Okay, we've got xp minus xq. We've got down here xq minus xp, so the top is back to front, but it's the bottom back to front as well. xp yq minus yp xq, yp xq minus xp yq. This is back to front. It's exactly the same as the answer. All we've got to do is switch the signs on the top and on the bottom, and we've got exactly what we should be having, basically yp xp yq minus yp xq. Yeah, which is s, yeah, as required. Now, I don't think I'm going to bother showing you how to derive x. I'll leave that for you, but you know, it's going to be exactly the same, but instead of timesing these by xq's, you're going to get rid of the y, so you're going to times it by yp and yq, and you're going to end up getting exactly that. Now, you know, that's probably easier than the trig. The trig just kind of feels like it shouldn't need to be there as well. But either way you slice it, it's a tough question, I'm afraid, James. It's just a really tough question. I noted when I did it, because I did it originally with factor formula and thought, and then managed to find the question. It came up on a specimen paper, didn't it? The specimen papers often have, you know, really very, very tough questions on it. Doesn't mean you shouldn't do them, you should do them, you know, because it's a case of like hoping for the best in the exam, but preparing for the worst, and so it prepares you for that really hideous question. And remember as well, you know, if the worst question on the paper you get 4 out of 8 marks on, you're doing really well. That's good. You know, it's not bad at all. Okay, so keep up the hard work, people. Hope it goes really well, and all the best. Bye-bye.